Alright, example 5. This is section 1.3 from Math 1060 Trigonometry. This section is called the unit circle. Find the sine of alpha and use this to plot alpha in standard position. Okay, so we're going to find, okay, so it's an acute angle, so that would be in quadrant 1. And cosine is 5/13. So it doesn't have to be unit circle. This is more section 6 stuff. But anyway, this is not drawn to scale. But if it was cosine, it would be the x value over the hypotenuse. Or if you wanted the hypotenuse to be 1, like the unit circle, then this side would be a fraction, 5/13. Okay. So I'm saying that this is my plot of alpha. It's not perfect. It'll be better after I find sine, because then I could stick to some sort of grid and have that at a specific point. Okay. So to find sine of alpha, I'm going to kind of abbreviate what we've been doing, which is to square root 1 minus 5/13 squared. So it'll be the square root of 169 over 169 subtracted by 25 over 169. So I was just looking ahead at what that number was going to be so that I could turn 1 into a common denominator, which gives me 144 over 169, which gives me 12/13. So again, the hypotenuse will be the same, and the opposite side is now 12. So you can totally see my triangle is not drawn to scale. So you can sketch that out a lot better than I did with a much bigger acute angle. Okay, so now find the sine and cosine of the following angles. If we add pi to alpha, where is that going to take our angle? Well, pi is 180, so that's going to take that clear around over here, right? So this would be pi plus 180. See if I can draw a straight line. So let's say this is alpha, and this is the angle we're looking at down here. Okay, so in quadrant 3, the answers are both negative. But it would be the same reference angle, wouldn't it? Because it's 180 degrees. So because it would be the same reference angle, that means that cosine would be negative 5/13 and sine would be negative 12/13. So same exact values, just a reference angle in a different quadrant, so negative instead of positive. Okay, let's think about what this one means. Here's alpha. So if we take 2 pi and subtract alpha, that's actually taking it this direction into quadrant 4, right? So we're taking alpha from 2 pi, so moving it that way. So quadrant 4 means that cosine would be positive. All students take calculus, so that would be 5/13. And sine would be negative again, so negative 12/13. Alright, what about 3 pi minus alpha? Ooh, so here's alpha. And 3 pi would mean that we're going all the way around to here and then subtracting alpha. So kind of like pi minus alpha, right? Because isn't 3 pi and pi like the same equivalent coterminal, right? So that would just be quadrant 2. So in quadrant 2 we have cosine is negative and sine is positive. Alright, don't get too comfortable with what's going on because we've got like something totally different about to happen. So now this time, we're going to take alpha and we're going to add pi to it. That's going to take it here. That means it has a different reference angle. So alpha is the reference angle in quadrant 1, but because we're adding 90 to it, the reference angle would actually be like 90 minus the angle, which means we're talking about the cofunctions. So it's kind of the same triangle that we would have up here, which I guess we would draw this way instead. Here, let me erase that because I don't like the fact that I drew that triangle the wrong way. So it would be this triangle, but it would be reversed over here. So if this side is 12 and this side's 5 and that side's 13, those are going to switch. So this would be 5 and that would be 12 and that would still be 13. So our circle has the same radius. What happens then is it's a quadrant 2 angle, so cosine is negative, but this time cosine is the sine value because the opposite and adjacent sides switch. And then sine will be the cosine value, the positive, in quadrant 2.